we've got to have a chat about resonance. If you don't understand resonance, you're never going to understand mechanisms, you're never going to understand major and minor products, etc. So why resonance? Let me explain to you how I rationalize the concept of resonance. Most atoms, unless they're electronegative, don't like having electrons. Therefore, if they have a minus charge localized on them, they're very unhappy. So what do they want to do? They want to give it away. For example, if you have a carbon with a negative charge, it is very unhappy. Carbon is not electronegative. Hence, it doesn't want the minus charge. So it says, can anybody help me? Can I move this around? Decreasing the load. For example, if you had to carry a 50-pound brick 50 yards, that'd be pretty tough. But then if you had a friend come around and help you, and every 5 meters, you guys would give the brick back and forth to one another, then it would be less hard. You guys would share that load, and it would be less awful for each of you. That is what atoms are doing with electrons via resonance. Thus far, we have learned that atoms, especially carbons, don't want to have a minus charge on them. Hence, they're going to want to move that minus charge around. They're going to delocalize it, decrease that load by sharing it with other atoms. But then you got to ask, okay, well, where does the minus charge go? Where do I put it? Do I just toss it 6 atoms down? No. Everything is linear. So if it's on carbon number 1, you got to share it with carbon number 2 before you can share it with carbon number 3. Consider this structure. This carbon, very unhappy, has a minus charge. So what does it do? Well, it says, okay, I'm going to share this with carbon number 2. So if I push 2 in between C1 and C2, then carbon 2 now has an extra bond. And since we can't break its octet, it can't have 10 electrons. A 2 in must be reciprocated with a 2 out, or that carbon will break the octet rule. Okay, who could break? Who could be a 2 out? Well, it's going to be a pi bond usually. Pi bonds are weak. So the CO, that second bond, the pi bond between the carbon and the oxygen, is going to break and go 2 up. And then we get our resonance intermediate. And now we ask, okay, is this more stable? And now we explain the whole point of resonance. This intermediate that we made is now more stable. Why? Well, oxygen is actually electronegative. Hence, the oxygen actually wants to have the electron, whereas the carbon didn't want to have the electron at all. So now it is happy. It's in its happy state. Still, this structure would like to not have a charge at all, but if it had to have a charge, and it does, it would rather that charge be on the oxygen, the more electronegative atom, than the carbon. Hope this makes sense. Let me know if you have any questions.